Hi and welcome. I'm Dean and I'm here today with Matt and Jeff. Pretty recently, something became possible. Lots of companies already have a distributed cloud storage strategy. That's not new. What happened recently is that the problem of getting a multi-cloud application strategy, that worked and that you could afford and scale, well, no, not possible. Not something that most companies could have until now. Matt's going to show and Jeff is going to explain some use cases for this new approach where the data, the configs, the parameters, and everything the app needs to run are now durable and persistent, even if the app needs to switch to a completely different cloud company in a different part of the country, even in an outage, any kind of outage, planned and unplanned. And so, guys, hello, Matt and Jeff. Tell us who you are and what you're working on these days.
Sure. My name is Matt LeBlanc. I'm a senior systems engineer here at Avesha. I've been in the Kubernetes space for roughly 3.5 years. I think I've been to 7 KubeCons at this point, and I've really been focusing in on how workloads can be brought into the Kubernetes space for the last portion of my career. Jeff.
Hi, my name is Jeff Lunsford. I work with technology teams to solve networking issues in the Kubernetes ecosystem. And I've worked for hardware and software companies for over 20 years. My journey has included network infrastructure, open source software, and data management solutions. And as these areas have actually converged, I've transitioned into the cloud native space. Now that we have a little background on us, let's talk about who is Avesha.
Yes,
we are the leaders in the multi-cloud secure Kubernetes connectivity space. Our founders have deep expertise in networking, cloud technologies, AI, and DevSecOps. This team holds over 100 patents. They have started several companies representing about $7 billion in exit value, including acquisitions by Cisco and Ericsson. Matt, you want to provide a quick overview of KubeSlice and the solution we're going to talk about today?
Sure. So today we have a little demo to show KubeSlice's capabilities in providing connectivity amongst heterogeneous clusters in this case. We're going to be talking about how we can make sure that we keep our scores alive from our PacMan application that's running across 3 of those clusters.
Very important.
How are we going to do this? Well, first, let's talk about what KubeSlice is, just so we have a little general understanding. KubeSlice is a cloud-native solution that allows you to securely connect, manage, and monitor connectivity to your clusters across any cloud and or on-prem with any flavor of Kubernetes. So that means it is deployed as an operator via Helm chart, and you can use this in any environment. So that means you can use this for your EKS, AKS, GKE, OKE, Red Hat, OpenShift, Rancher. It doesn't matter. We support them all. And we're also doing this with layer 3 networking. What does that mean? We're not doing it at the application level where most other solutions are. We are layer 3, which is low latency, which means a fast response for your applications. And we also do this with a flat network. So that 192.16.x, that is a non-routable network, which also adds to our security. And we don't use any NAT. That's a big feature. And to add to the security, we also have encryption, right? Using OpenVPN, we're able to keep that information secure. And of course, with a cloud-native solution, you'd expect multi-tenancy support. So we have very granular role-based access control to support your connectivity. Now, what does that all mean? Now, essentially, once you install KubeSlice into your environment, you're able to connect your namespaces. So we can connect your clusters, which what we're referring to as a global namespace, and that's what we call a KubeSlice, or slice for short. So in the example you're going to see today, we're going to connect the MongoDB, the Mongo database namespace for GKE, AKS, and EKS, and we're going to do all this live. Now, let's talk about what it would take to do this without KubeSlice. You're going to have to set up your VPC peering. You're going to have to create your inbound rules, set up load balancing, configure your DNS, and as well as do your exclusions from SNAT. In addition to those management functions, you're also going to have to manage this within the politics of your own organization. So if you're trying to connect your Google, Azure, and AWS clouds, you're going to have to go through probably a few different teams to get that done. A lot of coordination, which takes a lot of time and effort as well. Yep.
So the alternative to working through each one of these steps that Matt just outlined is KubeSlice. We've simplified the deployment process so you can connect clusters together in minutes, regardless of your Kubernetes distribution or where you're running it. For example, across different cloud regions, multiple cloud providers, or on any edge device. So think about it this way. No one knew the importance of sliced bread until we had sliced bread. So Matt, you want to do a little prayer to the demo gods?
Yes, may the demo gods shine upon me today. Let's talk about how we have this set up. So this is a multi-application solution. Yes, it is PacMan, but we have PacMan, the stateless application that's running individually on AKS, EKS, and GKE. We also have MongoDB Cluster Edition that is also running across those. And what we've done is basically set up that cluster edition so we're able to write our high scores. That's basically our database and what we're going to be visualizing today. In the demo, I'm going to kill the pod where that primary Mongo replica set is. We'll go into what that means in just a minute. But we're going to basically kill that application that simulates your cluster or your cloud is unavailable. And then you're going to see how the failover of the database is allowed to happen to the other cluster, and it's all because of the connectivity provided by KubeSlice. Why is this important? Well, I want to make it clear, just because I put AWS as the outage on this first page, I'm not picking on them. All of the hyperscalers have their outages. It's not just AWS. It's Azure, and it's Google. I actually like this one here because it gives you an idea of how long that duration is for those outages, somewhere between an hour and 43 minutes to a day and 4 hours. So there's a lot of variation, and being able to fail over without any human interaction and keep your data is going to be imperative for keeping your applications up and running and keeping that stateful set.
It always feels like a long time, no matter how short it is.
Oh, sure.
Seconds crawl by. And I just want to clarify.
Seconds.
When you start taking down, knocking down parts, you're going to simulate a catastrophic failure. It's not going to bounce back in 90 seconds, right? You're going to knock it all the way down.
Correct. So I'm going to go over and kill the pod that is running the database. So as you can see here, this is actually a screenshot of the of MongoDB, the dashboard here. And we're going to go to the live version of this, but you can see, let me grab my mouse here. Over on the right here, we have that replica set 2. Currently, it is you see the P, that is the primary replica set. There are 2 other copies of that. You see the other 2 are secondary with the S down the lower logo. But let me put this in terms that will make a little bit more understanding here. We're trying to keep the scores alive and the data behind that. So if we take a look here, you can now see our 3 replica sets. The one over on the right, which was listed as primary, that's our read-write set. The other 2 are read-only. And basically what that means is that each instance of PacMan is going to be able to get a quick reference to the local copy for read-only. And when they do the commit, it will write to whatever the primary set is. MongoDB clustered version basically is going to manage where these fail over to. It's KubeSlice that is allowing the connectivity. Now, as I mentioned before, each app is ran locally on each cluster. The high scores are kept on that Mongo database. We have the primary replica set, which is read-write. Our secondaries are read-only, and we're going to have a failover from primary to secondary if that cluster or when that cluster goes down. So let's get into it. Any questions before I go into this, Dean or Jeff?
You're dealing with the 3 hyperscalers, and all of our data centers are in different parts of the country, right? Like there's one in Amazon's is at the main one in Virginia.
Yes. Let's take a look at that. So I happen to have KubeSlice Manager. Right? So it is important to point out that this is an open source project, but we also have the enterprise version. So the enterprise version comes with the availability for dashboard. And to your point, Dean, we have each one. So we have our GCP cluster in US West. We have our Azure cluster in US West 2, obviously California coast, and then also our EKS cluster over in AWS, which looks like it's in Virginia. Is that what you're getting at, Dean?
Yeah, so you're not just knocking down, as far as the demo is concerned, you're not just knocking down one of the clusters, you're knocking down a big part of the country, and it won't matter.
Let's
see
just
it,
at some point we're going to fail a cluster, and we're going to make one of these basically go away.
This is the most often I've heard the words live demo and fail mentioned together in a long time. So let's see.
Let's see how this goes. All right. So before I get into it, let's talk about that database. So you saw this in the screenshot before.
Right.
I just reset this lab recently. So our primary replica set, you can see, is on 1, 0. So you can see that there's replica set 0, replica set 1, and replica set 2. Now, if I switch over to, I'm going to switch over to Lens. Now, this is a free tool that I use to manage my clusters. If you take a look here, I have 3 clusters. There's my EKS cluster, there's my GKE cluster, and there's my Azure cluster. And if I take a look, we can take a look that I'm looking at the pods there, and you can see replica set 0 is on EKS, replica set 1 is on Google GKE, and replica set 2 is on Azure. And if I flip back to that management screen, we can see that replica set 1 is the primary. So let's go back over there. And replica set 1 is on GKE. Now, let's get into the application, the game itself. I have 3 instances running, and each one of these is running in their respective cloud. And you'll see that up here. So here's our AWS cloud. Here's our GCP cloud, and here's our Azure cloud. Now, in order to get some data in there, and you can see here's the high score list. And if I look at each one of them, you'll see that it is the same high score list, even though that application is running local. So if we play the game, I'm going to play this very, very shortly. I'm not here to get the high score. I'm really here just to get a number up on the board. And let's go have one more pinky death. There we go. And let's see, let's timestamp this. 2:13 p.m. on the AWS cloud. Hit save. And we can see our high score has been updated. We're going to do that 2 more times. And again, I'm not going to play this long just to get some data on there. Oh yeah, I still got the sound on there.
I wanted the sound on. That's the best part of the game.
I kind of missed the waka waka of my childhood. All right, so now we have another score. We got 2:13 p.m. on GCP. Save. High score list, right? We can see that's clearly working. One more score. Let's add to it.
Please turn the sound on this time for the whole game.
All right, I'll turn this.
Absolutely.
There we go. We got the sound.
You remember when this was good graphics?
It's still good graphics.
Is it?
This is classic, my man. This will never go out of style.
All right. So now 2:14 p.m. on Azure. So this is called showing your work, right? You see me, I had some data in there. I've added a few more entries over to the high score list. Now let's break something. So I am going to go over to my Lens management console. And remember, we were running GKE. Right. I'm sorry, GKE is running that primary replica set, right? 1-0. Now, I could simply delete this pod, but as a function of Kubernetes, it'll just come back, right? Kubernetes is resilient. Yeah. It has the ability to recover. Before I do that, I'm going to basically temporarily cordon off, disable the scheduling so it does not just bring that application back up again. So now that I have scheduling disabled, I can go over and delete the pod.
Kapow.
Boom. All right. So now we are going to set our clock. I have the clock app. I know it's going to take roughly a minute and a half or give or take. And we're basically going to wait to see how that happens. I will get a notification You see the timer up here. We are live without a net. Now let's go over and take a look at our KubeSlice. I'm sorry, our MongoDB manager. You'll see, even if I refresh this, it still hasn't really gone down yet. It will take a moment. Now, what you're going to see here is how KubeSlice has provided the connectivity. And it's not just that we are connecting those clusters, we're only connecting those use spaces. And let me show you something that's a little bit more interesting here. I'm going to go to the host mappings. What is interesting? There's our replica sets. Notice they're using a 192 address. That is how they're communicating. So then when we say it is a flat network, that is how these three replica sets of Mongo are communicating. Let's go back.
So they all feel like they're on the same network.
They all think they're on the same network. We basically encapsulated, created that VPN tunnel, and they're using that 192 network to communicate. It's easy to manage, it's easy to set up, and it is also secure. Right. So one of the downsides of doing this without KubeSlice is essentially you'd have to open up ports to connect the two clusters. And the challenge of that is it creates what we refer to as the noisy neighbor scenario, which means if you connect cluster A to cluster B, everything in cluster A has access to everything in cluster B, which could be a problem. All right, so there's my little alarm. Let's go see how we are doing here. I'll go back and, oh, yes, I didn't even have to refresh. You can see cluster 1.0 is now down. And we have now failed over to the replica set 2-0. So let's see if this still works. So let's go over to our Azure. That's where 2.0 or that the replica set 2 is working. Right. We can see our high scores list as we saw. Here's our 3 examples. And let's hit
saved before the cluster went down. Yep.
Yep. And let's hit play. Oh no, let's turn on the Waka Waka. The dying sound makes me smile, quite honestly.
I'm interested in the high score. Is it going to show up now that that instance is down if I had gotten the high score?
I'm sorry, what was that, Jeff?
I'm interested in whether my high score is going to be saved. Is it going to show up in the other instance?
All right, so let's go. This is on Azure. Save. And go to that high score. All right, and we'll go back here and view high scores. Back, new game, play.
Ooh, color scheme.
I got to get enough score to get on there. Oh, I should not have taken the power pellet. I just got to wait for them to turn back again. All right. And here we go. And one more time. And we got 2:18 p.m. on our AWS cluster. Save. And there we go. So we've now managed to do that failover using KubeSlice to keep that connectivity. All right. Jeff, why don't you tell a little bit more about the other use cases that apply here?
Besides PacMan.
Yeah, I mean, yeah, PacMan. So we've been running into a number of different use cases when we're talking to enterprise customers. As you look at them, the hybrid cloud or burst to cloud edge deployments is one of them that we see a lot. Multi-cloud database resiliency, which you just talked about. Application isolation and zero trust. Zero recovery time objective or zero RTO. We also have real-time cluster observability and application migration. So I'm going to walk through these fairly quickly so you can just get an idea of what we're seeing out in the marketplace. We're happy to dive into these in more technical detail if you'd like, but you can deploy a slice across any Kubernetes distribution. Each slice creates a single global namespace for an application in your environment. You can run across data centers, cloud regions, multiple clouds, or even edge deployments, eliminating all the hard work that you would have to do on the left side of the slide, while getting all the goodness on the right side built into the solution. So when we look at use case 2, we're using that same slice or secure data path. We can deploy multi-cluster or multi-cloud stateful applications on Kubernetes. We can run these in active deployments and have them up and running in minutes and be fully ephemeral. This works with a lot of different technologies. So it could be things like Couchbase, MongoDB, Redis, Cockroach. We actually had a customer that wanted to run Keycloak in an active deployment for the single sign-on and do that safely on OpenShift. So that was something that we're able to do with a slice. It doesn't matter what the technology is. When you go to the use case 3, we're using that same data path. So we're using the same technology to achieve all of these different use cases. This is what we call zero recovery time objective. And what we're doing is working with any popular data management platforms in the Kubernetes ecosystem. Using that KubeSlice, we can create a fully redundant system by including a replica in another cluster. That could be in a different availability zone or on another cloud. In use case 4, we're using that slice to create application isolation or guardrails to help with like a zero trust initiative. We can secure your deployment, limit blast radius, and from application across your environment. This could be something like test, dev, and production, right? It could be a multi-tenant application, a banking app, for example, where you want to separate your customers. And this limits your blast radius. When you talk about use case 5, telemetry data, right? We can take all the telemetry data that's created in that slice across all of those clusters, and we can feed it into something like Prometheus or another monitoring solution if you want. By doing this, we can create real-time observability reports for the entire application, even if that cluster is spanning from data center to data center or multiple hyperscalers, and even if it includes different distributions of Kubernetes. So when you look at use case 6, this will be our last use case because it seems to be one of the most popular. And it's one that we're going to focus on in our next webinar. But because we're running that layer 3 virtual private network, we can seamlessly migrate any containered application from cluster to cluster or from data center to cloud or cloud to cloud. So you can migrate applications seamlessly without lift and shift. So why do you want to do this now? You need to build a redundancy and disaster recovery into your cloud native strategy. The complexity, the time to deploy, and the human capital required in the past are significant barriers. With KubeSlice, Avesha is an all-in-one solution. You can be up and running today, saving your organization months of time, human capital, and lots of headaches. So if you want to try KubeSlice in your environment, here's a link to a 30-day trial license. Our team is happy to assist you with any questions about setting up KubeSlice or diving into potential deployments in more technical detail if that's your requirement. So let's see if there's any questions.
Yeah, I've got like a handful actually that have been provided. So
nice.
Well, someone mentioned in a couple slides back, I guess you showed service mesh, and it's like, I mean, it's a pretty blunt question. Why do I need this? I already have service mesh set up.
Matt, you want to take that one?
Yeah, we're not here to replace your service mesh. This really provides your application connectivity. Service mesh really has a different function, and we're not here to replace or displace it.
Okay, so in addition to, basically.
Yes.
Okay. Can I mix together different setups like Couchbase on AWS, Redis? See, this is where my brain's going. Redis on Azure, different countries, things like that.
Yeah, I mean, one of the main advantages here is that you're able to leave the data where it's created and where it's being managed, and have other applications make reference to it. but you still have the security without having to create egress and ingress egress and make all adjustments to your firewalls and your VPC. So it's much easier to manage, allows you to take advantage of that data gravity where you may have a cloud or a cluster that has a lot of important information, and you have another cloud or cluster in a different cloud elsewhere. You now have access to that data and doing it in a secure and high performance fashion.
Okay. Jeff, I think this one is for you. Are there any use cases or anyone who should not expect to see much benefit from KubeSlice?
Wow. We think that it's a great platform to start out your Kubernetes journey because it does provide you that security. It provides you a way to start building your applications and then seamlessly migrate into a multi-cloud strategy, give you that redundancy, provide a DR facility. So if you start building there, it's great, right? I don't see a use case where it doesn't really fit in. We've even talked to people who are running, mainframe, and they're starting to do transformation on the mainframe and looking at running Kubernetes there. You could connect a slice to your mainframe and to your Kubernetes cluster potentially. So there's all sorts of ways that this can be used. Matt and I have kind of joked about this, that we haven't even seen the breadth of use cases. Every day we discover something new. It's crazy.
Okay,
It's
and then
a new tool available in your toolbox, and we, as Jeff had pointed out, we haven't even begin to discover all of the use cases that would make KubeSlice advantage for our enterprise customers.
Okay, and then I had one question that I kept all the way through. I just wanted to be clear about something. So, our demo showed 3 hyperscalers, right, in 3 different parts of the country. There's no reason why I couldn't use 2. No reason why I couldn't use 10. No reason why I couldn't have them spread around the globe. Or is there? I legitimately don't know.
So we work with Cox Communications on their Cox Edge platform, and they have 30 different data centers. So if you're spinning up an application in that environment and you want to have 2, 3, 4, you want to seamlessly add additional data centers as usage and location becomes an important factor for the application of the data that you're running. We can do that seamlessly, and you can add clusters or take them away as needed. And this translates to a lot of different edge cases that are coming online, especially when you start thinking about running AI and running that closer to the edge to cut down on cost of egress and ingress.
So keeping your data on the edge is one use case, or you could think about your data governance where data needs to reside within the country that's being managed. But
more and more common these days.
It may need to live, let's say, in Canada, but you could allow your clusters in other locations to have access to it in a secure fashion, where the data still lives in Canada, in this example, but you can access it from a cluster in a different region or a different country.
You could also think about retailers out there where they might have 2,000 locations and they're running Kubernetes now in their office as a kind of a data platform for the store, collecting a bunch of telemetry data and pulling that back.
Box store scenario, Jeff.
Yeah.
Let's just say the hardware store with the one with the blue logo or the one with the orange logo, they're all running K3S at their local retail, and they're also running a large cluster that is in one of the hyperscalers. And for that scenario, it would allow them to have easy secure connectivity for data protection. Just imagine. My guess is, and I'm not trying to pick on Florida, but they're currently being hit by a hurricane. And it is not uncommon for one of those hardware stores to lose a store to 3 feet of water. So this would be an easy way for you to connect to the mothership in the hyperscale and make sure that you have all of your retail data from today's sales before your K3S little server is underwater.
Right, in the closet in the back room of the warehouse. Yeah. Okay. All right, that was good. We kind of promised when we set this up originally that we'd take about 30 minutes, and it's been about 30 minutes. So I'm Dean. Thanks very much for joining. Thanks very much to Jeff and to Matt. I wish PacMan could have gone on a bit longer, but I understand we have time constraints. And thank you for playing the sound. I really appreciated that. I think it added a lot to the demo, actually.
Well, we appreciate the time and opportunity to talk a little bit about KubeSlice.
That was fun. All right. We'll be back next month with another episode. In the meantime, thanks, everyone. Have a good day.